Hello everyone, I am Sujata Moril. Welcome you all in the video lecture on the topic inverse J transform by convolution theorem. Now J transform is given by J transform of f of n equal to summation n equal to minus infinity to infinity f of n j to the power minus n. Its value equal to capital F of J. Now inverse J transform is given by Z inverse of capital F of Z equal to f of n. For example is this. Z transform of 1 and u of n is equal to same value z upon z minus 1. Therefore, z inverse of z upon z minus 1 equal to 1 or u of n. In this way, we can write down all formulas in this form. Then inverse z transform we can find out by four different methods. Partial fraction method, second is convolution theorem, third is residue method, and fourth one is power series method. Now in this video we are going to discuss convolution theorem second time. Convolution theorem. Now here this theorem is used for finding the inverse Z transform of product of two functions of Z. Therefore here Z inverse of capital F of Z and G of Z, its value equal to summation m equal to 0 to n f of n g of n minus m equal to fn. Here this star we call this as convolution operation and into g of n. Now for this we prove we consider capital F of Z and G of Z value. By using definitions we substitute the values by using definition. Then we expand the terms. This expand the terms by this method. By substituting n equal to 0, we get f of 0. J to the power 0, its value 1. Then n equal to 1, we get f1 j to the power minus 1. For n equal to 2, f2 j to the power minus 2. Similarly, for g of n into j to the power minus n, we substitute the values. Now, when we multiply these terms and combine the terms of j to the power minus n, we get this step summation m equal to 0 to n equal to 0 to infinity f naught g to the power n. That means we multiply the terms, then here f naught is multiplied with the gn, then we get j to the power minus n term. In this way, we combine all the terms and these are these values z to the power minus n and we give the summation, and by using the definition this is the z transform of this term. Now this z transform we can write down in the form of z inverse capital F of z into j of z equal to this value, and in terms of summation m equal to 0 to n fm g of n minus of m, and this value, this is the convolution theorem. Now we discuss problems on this convolution theorem. Using convolution theorem, find z inverse of this z square upon z minus a z minus b. Here z inverse by using convolution theorem, which is given by equation 1. Now z inverse of z square upon z minus a z minus b we can write down in the form of f of z value and g of z value, because product of two functions of z. Therefore, this is the first term, this is the second term. Now here z upon z minus of a, its z inverse is given by a to the power n. This is the value of fn. Now similarly here z upon z minus of b, here if we find out its z inverse, then its value is b to the power n. This is the value of g of n. Now here fm, therefore fn is a to the power n, therefore fm is a to the power m value. We substitute here this value. Similarly, b to the power n minus of m, here actually gn, its value is b to the power n, therefore g of n minus of m is b to the power n minus of m. This is the second value. Now we simplify this term. Here summation for m, therefore b to the power n is taking outside, and remaining term we write down in the summation m equal to 0 to n a to the power m b to the power minus m. Now we write down these b to the power minus m in the denominator, therefore a by b to the power m. remaining term summation as it is. Now we simplify this by substituting m equal to 0 to n. If we substitute 0 value, then we get 1. A by b to the power 1, m equal to 1, then m equal to 2. In this way, here m equal to n terms. Now this is the series in terms of in GP. Therefore, here and common difference is a by b. Therefore, we write down this as 1 minus a by b to the power n plus 1 upon 1 minus a by b. We simplify this by taking LCM. We get this term. Now combine the terms of b to the power n, b upon b n plus 1. This get cancelled. We get this is the required result. Now here this is the generalized statement, that means a and b values. If we have given this example, z inverse of z square upon z minus of 3 into z minus of 1, that means here value of this a equal to 3 and b equal to 1. In the, if we substitute this in this result, we get the required result, and if we solve the problem by same method, then we get the required result. In this way, we solve the problems of this by using convolution theorem. Now, next problem, example number 2, show that 1 upon n factorial into this convolution operation, 1 upon n factorial, its value equal to 2 to the power n upon n factorial, or this z inverse of e to the power 2 by z, its value equal to 2 to the power n into n factorial. Now here, by using convolution theorem, that means we have to write down in the two forms, f of z into g of z. Now here fn equal to 1 upon n factorial equal to g of n. Therefore, capital F of z of these values are same. Therefore, f of z and g of z value are e to the power 1 by z, same value. Therefore, by using convolution theorem, we write down the equation number 2. Therefore, z inverse of e to the power 1 by z into e to the power 1 by z, that means here f of z into g of z value is e to the power 2 by z, and its f of n into g of n value is 1 upon n factorial into this convolution operator 1 upon n factorial. Now we can write down in the form of convolution theorem summation m equal to 0 to n 1 upon m factorial into 1 upon n minus of n. Similarly here f of n is 1 upon n factorial, therefore we write down the value of fm, which is value is 1 upon m factorial. Similarly for g of n is 1 upon n factorial, we write down the value of g of n minus of n here. In this way, now simplify the terms by substituting m equal to 0 to n. Therefore, if we substitute m equal to 0, we get this value. Then m equal to 1, we get this complete value in this way for up to n. Now, if we taking 1 upon n factorial common from all the terms, then we get this equation number 3, this bracket value. Now, this bracket value is nothing but the expansion of 1 plus 1 to the power n. Therefore, here value of x, if we observe the terms here, value of x equal to 1. Therefore, we write down here 1 and then 1 plus 1, 2. 2 to the power n upon n factorial. Therefore, z inverse of this value equal to 2 to the power n upon n factorial. In this way, we solve the problems of convolution theorem. Thank you.